let us understand how we see the object. Here I am doing one activity in which we will observe how we see the object. For the time being, I am switching off all the lights. Now you can't see anything. Why? Because all the lights are switched off. Now I am going to switch on the lights. After switching on the light, you will observe that you can see all the things around the studio. How is this happening like this? This is happening because when the light rays striking to the object, it after reflection enters to our eyes. After entering our eyes, we are able to see the object. So the lights are invisible part but makes us the things visible. Refraction of light. So what is refraction of light? We have done the light property is that light travels in a straight line in one medium. But what happens if a light changes its medium? For example, if a light is moving in one medium and after that it enters the another medium, then what will happen? It is experimentally observed that the light changes its path, means show the bending property. So refraction is nothing, it is a bending of light when the light is traveling from one medium to another medium. In order to understand the refraction clearly, here I am doing a one activity. Here I am taking the two mediums. First medium is water and second medium is air. Here note one thing, that the line separating the water and air is a boundary, and where the light ray is strike, we have to draw the normal. Now make a incident ray from air, means light is coming from air to water. The point where it strikes, here the bending of light is now showing. How bending of light is possible? Understand one thing, that the water is different medium and air is different medium. The particles in the air is less. If the particles in the air is less, then no one is resisting or less particle resisting the speed of light. But in the water, particles are more, so they are resisting more light. If they are resisting more light, then the speed of light in water is less. Now in air speed is more and in water speed is less. There is some action takes place, so light show the reaction. The reaction is that the light is bending towards the normal. It means it is concluded that when the light is moving from rarer medium to denser medium, here rarer medium is air and denser medium is water, it is bending towards the normal. Repeat the experiment, but now the light ray is moving from water to air. The speed of light in water is less because particle is more, and the speed of light in air is more because particle is less. When the light is moving from water to air at the boundary, it is bending away from the normal. So it is concluded that when light is moving from denser medium to rarer medium, it is moving away from the normal. See the meaning of optically denser and optically rarer medium. These are related terms, means relative to each other. For example, we have two mediums, air and vacuum. So here air is a optically denser and vacuum is a optically rarer. In vacuum there is no particle is present, so the speed of light in vacuum is maximum, that is 3 into 10 raised to power 8 meter per second. And the another term is air and water. Here water is optically denser than air. So we can say that optically denser and optically rarer are relative to the another medium. This is the table in which it is written that the speed of light in different mediums. We have to remember only the speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second, and observe the other speed. You can see that when the optical density of the medium increases, the light speed is decreases. So we have to introduce the new term. Which is new term? This new term is a ratio of the speeds of the light in two mediums, and this term is called refractive index. Let us understand the term refractive index with an example. Here I am taking a glass slab in which light is coming from air to glass slab. Air is an optically rarer medium and glass is an optically denser medium. When light is moving from rarer to denser medium, it is bending towards the normal. Let the speed of light in air is V1 and speed of light in glass is V2. The refractive index of glass with respect to air is equals to speed of light in air, that is V1, upon speed of light in medium or in glass, that is V2. So refractive index is a ratio of the speed from where it is coming V1 to where it is going V2. Let's generalize the term taking glass as medium 2 and air as medium 1. So refractive index of medium 2 with respect to medium 1 is nothing but a ratio of velocity in medium 1 to the velocity in medium 2. We have two types of refractive index. First is absolute refractive index and second is relative refractive index. In absolute refractive index, medium 1 is a vacuum, and in the relative refractive index, medium 1 is other than vacuum. Why we are taking the absolute refractive index here? Because if the medium is vacuum, then the speed of light is maximum, that is 3 into 10 raised to power 8 meter per second. So for example, light is coming from vacuum to any medium. So refractive index of medium is nothing but velocity of light in vacuum, that is c upon v. Here the value of c is same, that is 3 into 10 raised to power 8 meter per second. And in the relative refractive index of medium 2 with respect to medium 1 is v1 by v2. Understand the term refractive index with an example. The example is like this. The absolute refractive index of glass is 2 and relative refractive index of glass with respect to water is 1.5. Now find the speed of light in water. Here see, the absolute refractive index of glass is 2, means refractive index is shown by symbol n. So Ng is given, that is c upon v. Here c is speed of light in vacuum, that is 3 into 10 raised to power 8 meter per second, and refractive index is given, that is 2. From here we calculate the velocity of light in glass, that is 1.5 into 10 raised to power 8 meter per second. Now the relative refractive index of glass with respect to water is given, that is 1.5. Now put in the formula. Relative refractive index means Ng with respect to W is equals to speed of light in water to the speed of light in glass. Here the speed of light in glass we have calculated, that is 1.5 into 10 raised to power 8 meter per second. Now multiply, we get 1.5 into 1.5, 2.25 into 10 raised to power 8 meter per second. So the speed of light in water is 2.25 into 10 raised to power 8 meter per second. Similar to reflection, we have a refraction in which incident ray is striking at the boundary of two mediums, medium 1 and medium 2. Here suppose medium 2 is optically denser than medium 1. So the light ray is bending towards the normal and this ray become refracted ray. Now draw the normal at a point of intersection at the boundary. Now the angle between the incident ray and the normal is called angle of incidence, and the angle between the refracted ray and the normal become angle of refraction. Now here are two laws. First law is incident ray, refracted ray and normal lies on the same plane, and second law is sine of angle of incidence to the sine of angle of refraction give a constant value, and this constant value is nothing but a refractive index, and this whole law, this second law, is nothing but a Snell's law. Let's see the two cases when there is no refraction of light takes place. It means the light is coming from one medium without showing any bending, it goes to second medium. The first case is when the angle of incidence is 0. When the angle of incidence is 0, the incident ray is coming with normal, so the angle of refraction is also 0. How? Sin I upon sin r is equals to constant. Sin 0 is 0, and from cross multiply we get sin r equal to 0. Sin r equal to 0 means angle of refraction must be 0. So the refraction becomes 0. The light is without any bending going in the second medium. This is the first case. And second case is when the two mediums have same value of refractive index, then the light is going without any refraction. Understand the property of refraction with the experiment of glass slab. Here take a glass slab on a white sheet and make the outline of the glass slab and name the glass slab as PQRS. Now make a inclined line on the PQ and fix two pins A and B. These two pins on the straight line means they are coincident with each other. Now put the glass slab again and see the pins from the SR side. You fix the pins C and D in such a way that they make a straight line. Remove the glass slab and extend the lines. The line AB, which is intersect at PQ, mark a point that is M, and the line CD, which is intersect at SR, mark the point as N. Now make a 90 degree upon M and N. These 90 degrees is nothing but a normal to the surface. Now you will observe that the line AB or AM is nothing but a incident ray, and join the line M and N. The M and line is nothing but a refracted ray, and there is a new line that is ND, and is nothing but a emergent ray. Let's see what is the meaning of emergent ray. When a ray of light is coming to a medium, means second medium, then from the first medium it is an incident ray from where it's originate. After refraction it become a refracted ray. Now this ray is going to the same medium, it become emergent ray. You have to remember the name. And now see the angles. The angle between the incident ray and normal is called angle of incidence. The angle between the refracted ray and normal is called angle of refraction, and both these are angle of refraction. And the angle of between the emergent ray and the normal is called angle of emergence. Let us understand the refraction through prism. Here I am taking the front view of prism in which we are seeing a triangle. Here triangle is ABC. AB and AC are the inclined faces, and the angle between these inclined faces is A. This angle is nothing but the angle of prism. Now incident ray from the left hand side. The incident ray striking on the AB surface at this point make a normal, and the angle between the incident ray and the normal is angle of incidence. Now this ray wants to go straight, but due to the change in the refractive index, or we can say that glass is more denser than air, so the light bends towards the normal. After bending toward the normal, the ray is going straight. This ray is now become a refracted ray. So the angle between the refracted ray and normal is nothing but the angle of refraction. This refracted ray is going toward the AC line. Now after AC line, first of all make the normal on the AC line at the point of intersection. You get the same angle of refraction, the angle between the normal and refracted ray. Now this ray wants to go straight, but due to change in the medium it is bending away from the normal, and this ray become emergent ray. The angle between the normal and emergent ray is nothing but the angle of emergence. Now extend the incident ray and the emergent ray. After extending, we get a deviation angle. This is a total deviation angle. What is the meaning of total deviation? It means ray is going toward this side, but due to this glass prism, it is bending toward this side. So this is a total deviation of the incident ray. Let's see the applications related to refraction of light. Our first application is when object placed in a denser medium view from a rarer medium, we see its depth less than their actual depth. Let it understand with an example. When a person is seeing or watching the surface of a swimming pool from the outside, he will observe that the surface is less than their actual depth. How is this happening like this? When a light ray is going from the surface of water to person's eyes, at the interface it bends away from the normal, because when the light ray is going from denser medium to rarer medium, it bends away from the normal, but our eye sees straight. Now extend this line to a straight. You see this extended line meet at a point above the surface of a swimming pool. Here we see the actual depth of the swimming pool, but the real depth is at the lower place. So we see the depth or imaginary depth less than the actual depth of the swimming pool. There are some examples related to the application of the refraction. You may note these examples. Now let us understand the natural phenomena occurring due to atmospheric refraction. Our first natural phenomena is the sun appears 2 minutes before the actual sunrise and sun appears 2 minutes after the sunset. It means we can say that advance of the sunrise and delay of the sunset by 2 minutes. So before understanding this advance and delay, let us understand how a person able to see a sun. If we assume the earth is a sphere, or sphere in the front view we have a circle, and a person is standing on the circle, means on the surface of the earth, and from the observer eye there is a horizon. If the sun is above the horizon, then we can say that a person is able to see the sun, and if the sun is below the horizon, then we can say that the person is not able to see the sun. Now consider the first case when sun is just rising. It means now sun is below the horizon. If sun is below the horizon, now the person is not able to see the sun from theoretical point of view. Let us understand the actual scenario. When light is coming from sun to the observer eye, light moves from vacuum to atmosphere. When the light is moving from vacuum to atmosphere, vacuum is a optically rarer medium and atmosphere is optically denser medium. So light bends towards the normal, but our eye or person sees straight. When we extend this line, a person is able to see the sun which is above the horizon. So sun is actually not rising up, but the person able to see the sun 2 minutes before the actual sunrise. Similar to the sunrise case, we have another case, that is sunset. In sunset, the sun is below the horizon, but light from the sun moving from vacuum to atmosphere, so it is bending towards the normal, but our eye sees straight. When we extend this light, we get a sun above the horizon. The sun is actually below the horizon, but a person is able to see the sun because his reflection, or we can say that the refracted sun is above the horizon. So we can say that there is 2 minute delay in the sunset. Reflection of light. So what is reflection of light? Reflection of light is a phenomena in which a ray of light, after striking to the surface, bounce back to same medium. This surface is called reflector, and the reflector is nothing but a plane mirror which we used in our daily life. In spite of the plane mirror, we have seen so many mirrors which show our image larger or smaller. For example, the side mirror of the car show our image smaller than us. So what type of mirror is this? These are the new classification of mirror. These are spherical mirrors. So spherical mirrors are of two types, concave mirror and convex mirror. Before understanding this concave and convex mirror, let us understand what is the meaning of spherical mirror. Here spherical mirror is nothing but a hollow sphere in which we are taking a small part of hollow sphere. Now we have two choices. Either we polish this part of hollow sphere from inside or we polished from outside. If we polish this from outside, then our reflecting surface become inside and this mirror is called concave mirror. And if we polish from inside and reflecting surface is outside, this mirror is called convex mirror. Now see some terms related to the spherical mirror. Here you see the spherical mirror forms a circle. These circles also have centers. These centers in the concave mirror is outside the mirror and the center in the convex mirror is inside this mirror. The points which are inside the mirror, we denote it with dash. So the center in the concave mirror is C and the center in the convex mirror is C dash. Here this center of a mirror are called the center of curvature of a spherical mirror. Distance between the center of curvature and the circumference of this circle is radius, and in this case this is a radius of curvature. There is a midpoint on the mirror. This point is called pole. The imaginary line between the center of curvature and pole is called principal axis, and the area which is used for the reflecting of light of a spherical mirror, that area is nothing but a aperture of a mirror. One experiment is conducted to both these spherical mirror. They are placed in front of a sun. From the sun, a parallel beam of light is coming and striking to both these spherical mirrors. In the concave mirror, these parallel rays converges at a point, and this point is nothing but a focus. And on the other side, these parallel rays diverges, and when we meet to appear this point in the spherical mirror, they meet at a point F dash, that is focus of a convex mirror. This new point is called focus, and the distance of the focus from the circumference or pole of the spherical mirror is called focal length. It is found that this length, focal length, is twice the length of the radius of curvature in both the spherical mirror. Now we are drawing three diagrams. These diagrams are very important in the image formation. Our first diagram is when the line is parallel to the principal axis, then the light after reflection passes through the focus in both the spherical mirror. Our second point is when the light is passes through focus, after reflection it become parallel to principal axis. And third point is when the light is passes through the center of curvature, it bounce back in the same direction. It means the center of curvature is acting as a normal to the spherical mirror. Now see what kind of images are formed when the object is placed in front of these spherical mirrors. In order to note all these things, we have to make a table in which there we write where the object is placed, means position of object, where the image is formed, means position of image, the size of the image, whether the size of image is larger or smaller than the object, and the nature of the image. Nature means real or virtual. Now before going to place the object in front of a spherical mirror, let us understand some terms related to image according to this spherical mirror. When the object is placed in front of a spherical mirror, the object should be placed erect, means above the principal axis. If the image is formed above the principal axis, then the image is erect, and if the image is formed below the principal axis, then image is inverted. If the height of the image is larger than the height of the object, then that image is called magnified image, and if the height of the image is less, then that image is called diminished image. If the image is formed outside the spherical mirror, then the image is real in nature, and if the image is formed inside this spherical mirror, then the image is called virtual image. Going to start the formation of image in front of a concave mirror. In these ray diagram, the three diagrams which we have done earlier are very important. Now I am going to start the ray diagram. Before going to start the ray diagram, first of all make the sketch. This is a standard sketch in which we are making first arc. In the arc we will polish the surface. According to the type of mirror, we will polish the surface. In this case, concave mirror have right side polished and left side reflecting. Now take a midpoint P, that is pole, and there is a center of curvature C. Now make a dashed line from these 2 points. This line is called principal axis. Now our raw diagram is completed. Now we have to place the object. The object placed is nothing but a line of 1 centimeter. Now I am going to place an object beyond C. When we place the object beyond C, first of all write in the box the object position is beyond C. Now see the three diagrams. Whichever rays you are like, you can use those rays. Our first line is when the ray is parallel to principal axis. When the ray is going parallel to principal axis, it passes from focus. And another I am taking when we are passing it from center. When we passing the ray from center of curvature, it bounce back. Where they meet, the image is formed. Now the point of intersection meet with the principal axis. Now the position of the image is between center and focus, and height of the image is less than the height of the object, means size is diminished. Now this image is formed outside the concave mirror. So this is in the real world. So in one case our nature is real, and this image is formed below the principal axis, means inverted. So our nature is real and inverted. Observe the table which we have made now. The object is placed beyond C. The image is formed between center and focus. The size of the image is diminished, means smaller. The nature of image is real and inverted. Let's start the second case in which I am taking the object is at C. If the object is at C, make a 1 centimeter line at C. Now the object is at position of C, so we can't make a line which passes from C. Now we have two options to make the ray. Our first option is when the ray of light is parallel to principal axis, it is passes from focus. And second case is when the ray of light is passes from focus, it become parallel to principal axis. Now they intersect at a point. Now meet this point. Here you will note that the image is formed at C, and the height of the image is same as the height of the object. Now start filling the box. The position of image is at C. The height of the image is same as the height of the object, means same size. Now see the nature. This image is formed outside the concave mirror, means real, and this image is below the principal axis, means inverted. Let's see the third case when the object is placed between center of curvature and focus. Now make a 1 centimeter line between center of curvature and focus. Now here I am taking the two rays. First ray is when the line is parallel to principal axis, it passes from focus, and second ray is when the light ray is passes from focus, it become parallel to principal axis. Now see the intersection point and meet the intersection point with the principal axis. You will observe that the image is formed beyond C. Now fill the box in which image position of image is beyond C. you will observe that the height of the image is larger than the height of the object, so the size of image is enlarged, and this image is formed outside the mirror. It means this is a real image, and this is below the principal axis, means inverted. So nature is real and inverted. Coming to the fourth point, when the object is placed at the focus. Here is one restriction, is that object is already at focus, so if we can't take the ray diagram in which we directly pass the ray from focus. So we have to choose another two diagrams. Now make a 1 centimeter line at the focus. Now take a ray diagram in which a line is parallel to principal axis. After reflection it passes to focus, and another line we make a straight line with respect to center. Now make a straight line with respect to center, and after reflection it passes through center. Now you will observe that these two rays are parallel to each other, and parallel rays meet at infinity. So the position of the image is at infinity. The size of the image is highly enlarged. Why highly enlarged? Because these are meet at infinity, means far from principal axis, and the image is too high. And the third case is image is formed in front of the mirror, means in the real world, so nature is real, and below the principal axis means inverted. Coming to the fifth point, when the object is placed between pole and focus. Now make a 1 centimeter line between pole and focus. Now make the same ray diagram which we used earlier. First line is line parallel to principal axis, it passes from focus, and another I am taking the ray which is with respect to center. You will observe that these rays are diverging in the real world. Now extend these rays to the mirror. These rays meet in the mirror, so image is formed inside the concave mirror. Now see the position. The position of image is inside the mirror or behind the mirror. The size of image is larger than the size of the object, means enlarge, and the nature of image is it is inside the concave mirror. So image nature is virtual, and this is above the principal axis, so it is erect, virtual and erect. This ray diagram is very important because the uses of the concave mirror is all because of this ray diagram. We see in the uses, when object is placed in front of a concave mirror, the size is highly enlarged. Why highly enlarged? This is because when the object is placed between pole and focus, then we get the highly enlarged image. Sixth and last case is when the object is placed at infinity. When object is placed at infinity, a parallel beam of light is coming which is parallel to principal axis, and after reflection it passes to focus, means all the rays converges to focus. Now start filling the box. The size of the image is point sized because point is formed. The position of the image is at focus. The nature of image is because image is formed outside this mirror, so nature is real, and we have done in real we get inverted image in case of concave mirror, so we get real and inverted. We have completed all the ray diagrams related to concave mirror. Now let's start the ray diagram of convex mirror. In the convex mirror, in order to make the ray diagram, first of all we have to see all the three diagrams related to the convex mirror. Now how we make the convex mirror? First of all we have to make the arc like this. Now start polishing the convex mirror. We have polished the convex mirror from right and the reflecting surface is left. Now mark a center of curvature and focus. These are inside the convex mirror, so these are shown by dashed line. Now make a pole and principal axis like this. After making all these, now we have to place the object in front of the convex mirror. Our first case is when object is placed in front of a convex mirror. In this case, you have placed the object anywhere in front of a convex mirror. Now make a 1 centimeter line anywhere in front of a convex mirror. Now we are choosing two rays. First ray is when ray parallel to principal axis, it diverges from the convex mirror with respect to focus. And second case is when the line is passes from center of curvature, they bounce back from the convex mirror. In the mirror, they may meet at between pole and focus. And now our image is formed between pole and focus. Now start filling the box. Object is placed in front of a convex mirror. Image is formed between pole and focus. The size of the image is smaller than the size of the object, means diminished. And nature of images, this image is formed inside the convex mirror, means virtual image. And this is above the principal axis, so this is erect. So nature is virtual and erect. Our second case is when the object is placed at infinity. When object is placed in front of a convex mirror placed at infinity, a parallel ray of light is coming and strike toward the convex mirror. These rays diverges with respect to the focus, and the image is formed at focus. This image is formed a point sized. So where is the object is placed? Object is placed at infinity. Formation of image, position of image is at focus, size of image highly diminished, point sized, and the nature of image is virtual and erect, same as the above case. I have completed all the ray diagrams related to concave mirror and convex mirror. Observe the cases from concave and convex mirror that concave mirror formed enlarged image when object is placed between pole and focus, and convex mirror usually form diminished image. So after observing these things, we have to see the uses of the concave and convex mirror, which are very important. Let's start the uses of concave mirror. Our first use is concave mirror is used in a solar furnace. In solar furnace, when concave mirror is placed in front of a sun, these sun rays converges at a point. That point is called focus, and in this focus we place the water in the metallic container. This metallic container heats up due to large amount of heat is focused at this point, and the water in the container is vaporized. This water is then used for industrial purpose. Our second point is concave mirror is used by barber for shaving, because we know that when object is placed between pole and focus we get enlarged view. Now we get enlarged view of mouth, so this is used by barber. Our third point is these concave mirror are used by dentist and ENT doctor. Let's see the uses of convex mirror. We know that convex mirror is a diverging mirror, so it is used as a reflector in the street light. Because it is a diverging mirror, it diverges the light in all the direction. Our second point is it shows diminished images, so it is used as a security camera in a big shop. And second point is it is used as a side mirror in case of car to see the rear view of the cars. Our next topic is dispersion of light. So what is dispersion of light? First of all, see the definition. The dispersion of light is like this: when white light is passing through a prism, it is splitting into its constituent colors. What is its constituent colors? What is the prism? Let us understand. Prism is nothing but a rectangular glass slab in which two surfaces are inclined to each other. And when the white light is passing through this glass prism, we get a 7 color, a band of 7 color, and this band of 7 color is nothing but a spectrum of light. Now let us understand the cause of dispersion of light. Before understanding the cause, first of all see one thing, that a white light is made up from different wavelengths of light. The speed of these wavelengths of light is same in vacuum. So when these light is entered to the glass prism, each wavelength experience different diversion, or we can say that each wavelength experience different refractive index. A higher value of wavelength experience less refractive index, and a lower value of wavelength experience more refractive index. When the wavelength of light is more, it means for that light refractive index is less. If refractive index is less, then deviation is less for that light. On the vice versa, if the wavelength is less, then refractive index is more, and if the refractive index value is more, then deviation for that light is more. In this case, red deviate least and violet deviate most. It means red is having higher wavelength and violet is having lower wavelength. Let's start the new topic, that is formation of rainbow. After rain, there are so many water droplets present in the atmosphere. These small water droplets act like a prism. When sun's white light is passed through this droplet, it first refracted on the first face, and after refraction, it becomes total reflection phenomena. It suffers total reflection phenomena, and after total reflection phenomena, it again dispersed from the other surface. This dispersion makes the light splits into 7 colors. So in this way, a rainbow is formed from the droplets. Let's see the two main reasons in which we are able to see the rainbow. What are the two main reasons? First main reason is there should be sufficient droplets of water in the atmosphere. These droplets may be from the rain or maybe from any other artificial conditions. And the second condition is the sun should be behind the observer. If the sun is in front of the observer, then he is not able to see the rainbow. So sun should be behind the observer.